Okay, in this lesson, we're going to find the surface area of cones and cylinders. So let's start with a cylinder. So when you look at the surface area, think about what the shapes are. We'll start with the top and bottom. The top and bottom are just circles, right? So we already know the formula for the area of the circle. So I'm just going to write that down over here. Surface area equals, for a circle, it's pi times the radius squared, right? And there's two of them, so it's 2 times pi r squared. So that's for the two circles. Let me just write that here. Okay, 2 circles. Now we have to add onto it the side. So imagine, if this was a can of soup, which is a really common question, right? What would be the area of the label that wraps around this can, right? Around the outside, okay? What would the area of that be? So if you take that and imagine again that label that goes around a can of soup. If we cut that label, like we cut it down the center, and then we unrolled it, what we'd end up getting is a rectangle here. So the area of a rectangle is really easy, right? It's length times width. Okay, so what's the length of this thing? Or let's start with the width. That's the easy thing. The width is just the height, right? Look at it. In our example, it's 20, right? So the width here is the height. Now, what is the length across going to be? Well, all it is if you think about it, the length of that can, again, imagine that label wrapped around a soup can. That label wrapped around from here to here, that is this measurement from here to here, right? That's that width or length, whatever they're calling it, the length here. Okay, so that's this length here. So all it is the circumference of a circle, right? So all it is the circumference of a circle. So it's height times the circumference of a circle. And what's the circumference of a circle? 2 pi r, or pi times the diameter, but we'll use 2 pi r. So that's a formula we already know. So we actually know all of this. So again, I'm just going to write here, this is the circumference of a circle. All right, so this is good stuff, especially when you're going to get into trickier questions in future grades and you start breaking down shapes to understand this stuff, okay? So circumference of a circle. Now, what do they call this piece here that wraps around? They call this on your formula sheet, they call it the lateral surface. So let me just write this down, lateral surface. Now, lateral has some different meanings, but generally in math it means the side. So you can think about the side's surface, right? Or what is the side, okay? So again, how did we figure that out? It was height times 2 pi r. So I'm just going to put that together like this. 2 pi r times the height. And there you go. There's your two pieces that make up the entire surface area of this shape. Now, the thing we got to warn you about is usually in math questions when you get into, if we had been in the class, they're going to be pretty simple, but you still got to watch out. Usually you get a question that would be like someone's painting the outside of this thing, right? But they're not going to paint the bottom. So you can't just use the formula blindly, right? If I'm not going to paint the bottom, I wouldn't use 2 circles. I'd change that 2 to a 1, right? Or it might be like the soup can example where they say they're only going to find the area of the label that goes around the outside. Then I wouldn't use this formula at all. So you got to be careful. This is why I'm not saying, oh, hey, just copy the formula off the formula sheet and go to it, okay? Why I'm saying sometimes you have to modify the formula to suit what you're trying to do. All right, so let's plug in everything and let's find the surface area of this can right here. So what do we got here? We got a height of 20, so we're gonna make the height 20, and we have a radius, and I know it's the radius because the line's only drawn halfway across, of 4. All right, so we can just punch that on the calculator. Now we gotta calculate these separately and then add them together. So don't punch this all in your calculator all in one step. I'm gonna put a dot because it's gonna be approximately, because I'm gonna round this. So when I calculate 4 squared, which is 4 times 4 times pi times 2, I get 100.53 approximately. Always try to write down at least 2 decimals, so when you round it to 1, it's pretty accurate, okay? And then when I multiply 2 times pi times 4 times 20, I get 502.65. I'm going to add those together, and then I'm going to round it to 1 decimal place, and I get approximately 603.2 centimeters squared. Remember, it's centimeters squared because it's still an area. Even though it's on a 3D shape, we're finding the area of all flat two-dimensional shapes, right? Like this is a flat circle. This is a flat two-dimensional circle here. This is a flat rectangle when we unroll it. So all our surface area formulas are basically what would happen if we unrolled these shapes and laid them flat and then found the area of them. That's what we'd get. All right, so let's check out the cone next. This is a pretty short lesson. All right, so to find the surface area of a cone, what we need, remember the difference between the slant and the real height. The real height is this line, let me get a different color pen here, going up the center, right? From the bottom center all the way to the top, to that vertex there. That's the real height. But when we're calculating surface area, we want the slant height, which is diagonal, right, going up and down this way. So remember, sometimes we have to use Pythagorean theorem to find one or the other. So we got to be careful. So when you look at the formula sheet, this is the formula it gives you. It says surface area of a cone is pi rs plus pi r squared. So let's figure out, well, why is that formula, right? So let me get rid of this. So the pi r squared should be pretty obvious because that's just a circle, right? So that's the area of the circle at the bottom. That's this shape. And again, with cone questions especially, imagine this was an ice cream cone or something flipped this way, right? They might say, what's the surface area of just the cone? If that's the case, I don't want that as part of my formula. So be careful when you look at the formula sheet because it's got it broken down into several steps. Now, the part that is the lateral surface, which is the side, which is the cone part, is pi times the radius times the slant. So that's the actual cone, okay? And how do we calculate, how did they come up with that formula? I won't bore you too much, but think about if you took this cone and if you cut it open, you basically get this, right? And it's a segment of a circle, okay? So if I took this and wrapped it around, it's kind of hard to show, but if I took this and wrapped it to there and connected up, we took this a piece of paper and cut it. I won't bore you with like a half-hour activity of doing that. There's all kinds of YouTube videos of people doing that. You can look them up if you want. But if you take that, just look up, formula of a cone, right? Surface area of a cone, and there's tons. But if you take that piece of paper, you cut it, you wrap this to that end, you get the shape of a cone. Okay, so I've got some more written here on your sheet if you'd like to read about it. But again, be careful. When you know the radius, right, and the height of a cone, you can determine the slant using Pythagorean theorem. So we got to keep that in mind. We're going to need that, okay? All right, so let's check out a couple, just 2 questions here. Now, the first one, they give me the slant, right? It's labeled on the side. So this is the slant, right? I don't need the height. They didn't give it to me, but I don't need it. And they gave me the radius. So if I want to find the surface area of both parts, right? Well, what is it? It's pi times the radius times the slant. That's the cone. Plus pi r squared. That's the circle, okay? So this part here, pi times 1 times 2 is the slant. Plus pi times 1 squared, right? Now 1 squared is just 1, and 1 times pi is just 3.14. 2 times 1 times pi is 6.28. And again, I'm just going to put approximate. That little dot tells me that I've rounded each of these numbers, right? Because if we don't put that dot, it means those are the exact answers, and that's not true. So I know it doesn't seem like a big deal to some of you, but the idea is if you want to, progress in math and you want your work to be taken seriously, these are the little details that people, not just your teacher, but people in the future, pick up on and are looking for, right? In your formulas and your solutions in the science world. All right, so let's add these together, and we get approximately 9.4 meters squared. Now again, if I only wanted the circle, that's the circle's area, right? If I only want the cone, that's the cone's area. And often you only want the cone, so just be aware. All right, now this last one here, we need the slant, okay? They gave us the height. We don't want the true height. We want I'll use S for slant, right? But this is just Pythagorean theorem, right? C squared equals A squared plus B squared. All right, so this side is our C, the side that's across from the 90-degree angle. The other two can be A and B. Doesn't matter who's A or B as long as we get the C, right? So I'm going to make the C into an S equals 8 squared plus 3 squared. All right, so S squared equals 64 plus 9. We're going to add those together and then take the square root of it, which is 73. Now, I'm not going to calculate that yet. I'll save it till I need to use it in my next formula. So my next formula, surface area, pi times the radius times the slant plus pi r squared, right? So what I'm going to do is I'm going to calculate it in this step. It's just a lot neater to leave it. You can, if you want to calculate it right away, you can. But it's a lot neater just like, why don't we just wait and just put it in to the slant right there, right? Okay, so what do we got here? We have the height. No, the slant is what we need, sorry. The slant is square root of 73, right? That's that guy right there. Our radius is 3. Our radius is 3. All right, so the first one, when I go pi times 3 times the square root of 73, I get approximately 80.52. Let's put the little dot there to say approximate. Plus, don't forget to do the 3 squared first, right? 3 squared is 9 times pi is 28.27. And now we can add those together. I'm going to round to 1 decimal, approximately 108.8 centimeters squared. All right, cool. So the only thing you really got to look out for is sometimes you got to use Pythagorean theorem. Anytime we're dealing with cones or pyramids or triangles, there's a good chance you have to. That's something you should always stop and say, hey, wait a minute, do I have to use Pythagorean theorem here or not? All right, thanks. Check out the next 2 lessons. They're pretty short.